Step 3. Function response for the process. Determine the character of the dynamic behavior of the process of the control component with the input with the artificially applied with the output response that follows if it's observed for the purpose of the comparison of the input signal that is applied with the must follow with the definite pattern. Figure 3.1 show the three typical patterns of the input signal are shown with the step function, and the ramp function, and the syncytial function. Step function input signals and time input signal with the ramp function and step input signal with the syncytial function. The RAM function corresponds with the gradually changing input signal that hardly even today with the control system analysis through input with the interesting information regarding with the response to the element with the analysis with the proportional plus the reset plus the rate controller. Chapter 4 does make it use of it, however the preferred approach with the step function and syncytial or frequency method of which if it is discussed in this and the next two chapters. Method results with the equivalent index for the determine the step function response for the process includes between the according with the control variable and provision for the manually loading final control element together to be automatic into manual with the transfer switch for the test is made with the under the operation condition. Load changes must be eliminated for the duration test eliminated change with the set point during the test must be permissible. Arrangement is illustrated in figure 3.2 of which for the control variable is pressed for the control is disconnected with the final control. Alright, so we have the air supply going to the final control element with the manipulated variable to provide for the control variable and then back to the control variable and a grounded time roll arrangements element with the control manual with the sudden manual with the chain with the air pressure applied with the final control element result with the chain with the process with the pressure record with the call with the step function response. Step chain with the valve position should be small with the possible the reason for the interpretation step function for the response with the assumption linear response that generally holds true only with the sufficiently small step changes. However, the more non-linear over the operating range is considered the response with the valve in which the 1/4 inch is entirely different with the response for the same value of 3/4 inch and the step change but it should be repeated to have the various valve position condition for the installation so allowed. Step change with the vary for the energy for the inch for the process for the manipulated variable the engineering energy change shows up to the process for the variation potential for the kinetic energy but also the chain with the energy law for the inherent with the majority of the process step with the function response with the consider the record with the method by which the addition loss of energy of the process takes place. It is probable to read the step function response for the process for the three basic characters with the dead time of the time constant for the result with the resonance for the capacity profit of the game discussed further below. With these data with the determined with the control action should be substituted with the value with the various adjustment controllers should be set with the two basic forms of step function response with the illustrated in figure 3.3 with a highly idealized pattern but do not contain with the main components of the particular response. Figure 3.3a represents step input 3.3a step input process response without self-regulation time and process response self-regulation. Some of the manual chain with the signal under the normal operation condition for controlling output signal with the figure 3.3.4 and 3.3c are two typically different forms of response with the step and input with the controllable variable process without self-regulation. These respond with the figure illustrated in figure 3.3b with the typical process with it stores up with the potential and with the constant rate without altering with the energy loss that may occur with the inherent characteristics of figure 3.4. Example showing with the tank of the liquid level of the control system and the main pump. The pump maintains output flow constant valve control, the inflow when it's above the level of initial equilibrium. Step change with the valve increases and shows a processing without self-resolution. Step change valve flow in, then goes out of the pump flow constant. Input level of the base balance for the output remains constant. Level considered the right of the new balance that never reached the profit of the response with the form that says they have no self-regulation. So the balance for the output remains constant. The level of the rise for the new balance for the never reach. The process for the response with the form is called with no self-regulation. Or the rate of response with the ratio of the response with the time that it takes place with the sense C with the magnitude with the control variable to change with a certain amount with e.g. C1 and C2 with conveniently expressed by lowercase c with the time interval of time 1 and time 2, which is required to produce the incremental C as change expressed in T with the rate of response for the process for the self-regulation is through variable express. So you have variable is equal to change over time. Process with self-regulation. The response with the figure 3.3, the difference with the C with the 3.3b with the graduation curve with a new value. C with the response would correspond with the arrangement of the figure 3.5 with the liquid engine for the tank with the constant flow. And process with self-regulation step change with the valve and the flow out. rate. The rate of the liquid leaving the tank depends on the valve with the opening level of liquid. Assume with the figure 3.3c with the representative chain with the level. Assume with the figure 3.5 with the step chain with the valve with the position. Introduce manually means close the valve slightly. Inflow with the now 6c with the outflow below level of the tank grab with the also level to right with the hydraulic head to increase the offset with the increase in the head causes the outflow and flow to increase eventually with the new valve position with the inflow again balance with the outflow. Though the new balance has been retrieved, even without benefit of the automatic controller, although the offset may be considered the ability to reach the balance in the manner of the known as self-regulation. Another example of the temperature control profit the increase the heat input balance for the increase the heat loss of the surrounding atmosphere, similar self-regulating condition. This is the majority of the industrial profit the gain, the response rate and time constant. Response given the self-regulated profit figure 3.3c, but it is determined the two conditions of the process gain of the response rate. The gain of the total chain with the magnitude of the control variable with the per human the corrective action final control element, subopposed with the step of the input with applied with the final control element, moved by 0.1 inch. Pressure chain with the thereupon will gradually until the settle with the 20 psi above the initial value of the process gain with the curve of the 20 to 0 over 1, 0.1 or equal to 20 psi an inch value with the motion of the algebraic expression that reads G is equal to C with the G of the process gain L equal to C incremental process variable for given the step of the final control element over the magnitude of the step chain with the response rate maximum chain with the control variable per unit with the corrective action of the final control element. The figure 3.6 with the illustrated with the response with the chain profit the variable magnitude step of the input with the maximum chain with the per unit with the time at the beginning with the response with the all three K with the speed with the express with the eye with the line drawn with the tangent initially maximum slope with the curve steep of the tangent line with the faster with the response some of the over the step line moving the final control with the element of 0.1 resolve with the response with the maximum change 50 psi per minute with the control variable with the response rate with the change of 50 over 0.1 is equal to 50 psi a minute and inches valve motion designation process gain with the end the rate of response by V two are combined with the commonly called with the time constant by writing time one is over the gain over the rate of response, and it shows step 3 step function response with the various magnitude step input outputs on the chart. Insert the numbers example the process gain response with the result of the time. Time 1 is equal to 200 over 50 200 over 500, which is 0.4 minutes since showing the gain over change over the magnitude. It may also be written with the time one over the change over the multi-magnitude versus over the variable. During the moment of the process without self-regulation, quit everything with the give it the finite hinge for the time constant, and also infinite various definition of the time constant. Time constant is defined with many different ways. Magnitude is always expressed with one definition. Time constant is expressed with the time control variable needed the past with 63.2% of the total chain with the illustrated figure 3.6 with no matter with how big the step of input with the give it the process. Control variable will always read for the 63.2% of the final value within the same amount over the time, which is given in the time constant 1. The tangents which are drawn within figure 3 with respect with the maximum speed with the response with the ratio with the total chain with the control with the variable T1 time 1 equal to the initial speed with the response only necessary multiplied with the ratio with the magnitude step of the input and 2 with the output with the rate over the process, and that is the magnitude of the input 3 over the change 3 over time 1 equals the variable. Similar to with the magnitude 2 is equal to the change 2 with the time 1 is equal to the variable. With where U is you the suffix 3 and 2 with the indicator with the different magnitude with the step of the even involved with the how with the total chain with the control variable divided with the magnitude step chain with the equal to with the gain as in change 3 of the over the magnitude of 3 is equal to change 2 with the magnitude of 2 equal to G of the gain. Substitute with either expressed with the 3 2 or 3 3 gain is equal to over time 1 is equal to the variable or time 1 is equal to gain over the variable. Which of the same expressed with the time constant equation 3-1 figure 3 for the others for the time constant can be with the name of the line, which is drawn tangent initial speed with the response with the time of the line reached with the final value with the control variable with the time count with the process with the dead time multiple capacity. Figure 3 show with the compare with the step function with the signal with the process with the response with the time and the interval with the time 2 with the elapse with the between the input with the beginning with the response with the time interval is the dead time over the process. The dead time is frequently with the approximation K with the multiple capacity profit mentioned for the chapter 1 with the time with the constant with the result with the resistance capacity that exists for the practical always number of variation resisting the capacity and additional profit the occasional of the our capacities for the consider the larger of the others. For all our practical purpose, justified speak with the signal, speak with the capacity, profit, the respond with the signal, capacity with the process. Consider the figure 3-3 and 3-7 the most frequently, however the 2-3 over the occasionally have the more capacity with the combined. Show the step of the function with the profit, the dead time with the response with the input within the magnitude up. Time over the left and the right. Change the process for the chain with the dead time over the time 2 within the curve. Result of the capacity of the S shape with the curve, the drum figure 3-8 with the sharp with the distinction with the dream of the time 1 with the dead time 2 with the law for the concept of the dead time. One side with the important with the evaluation control system approximation with the U with the proof with the sufficient accurate approximation with the get with the sum with the U with the tightly slightly modified with the determined adjustment proportional with the position control. Refers to the J.G. Ziegler and M.B. Nicholas within their classic paper, the optimum setting for the automatic control of the process leg for the automatic control circuits, published in American Society of Mechanical Engineering Transaction 1942 and 1943, respectively. So the step input with the magnitude and the change respond with multiple capacities can change with the time, dead time, end time 1, and then B. It is mentioned for the line of the drawn tank with the initial speed with the response intersect the fine valve with the process respond with the after time 1. Time initial speed with the respond with the K with the equivalent with the maximum speed with the respond with the S shape curve with the figure 3A with the maximum slope and speed respond with the bend with this S with the point with the inflection with the line with the jaws the tangent with the respond with the curve with the point of inflection point with the intersection with the basket with the minimum and maximum value with the response curve with the mark to AB with respect with the time between the 2 point with the considered time 1 with the time between the step of the input with the first and 2 point with the dead time 2. There are approximations which have given, proving the very successful and practical use it will be used throughout this text. Dead time is called by either transportation lag figure 3-1-3 or by additive effect with multiple capacities. Chapter 4: Step function response adjustment of the controller.